I welcome you all here in CEC-UGC Gurukul Live lecture. Myself, Dr. Pravita Kumar, Associate Professor, Department of Chemistry, Shri Aurobindo College, University of Delhi. Learners, today we will discuss dyes, colors and constitutions. On your screen, you are looking different lovely shades of colors, and these colors can be obtained, can be developed by applying dyes or by the application of dyes, by the applications of dyeing process on materials or on the textiles by the process of dyeing. Learners, have you think about it? What are the dyes? What are the relation between dyes and colors, and what are the organic compound present in the colors or in the dyes, and what are the classifications of dyes? Today in this lecture we will discuss dyes, colors and its constitutions. Learners, the use of dyes has begun thousands of years ago, and it is stated that over 10,000 of different dyes used by manufacturer in our industry, and also over 750 tons of different dyes produced annually today in the world. So you can understand how the dye important in our life. We can use dyes in printing, in textile industry, in food industry, in pharmaceutical industries. So archaeologists have found evidence of textile dyeing back to Neolithic period or New Stone Age, and also some data found that the natural dyes from plants, barks and insects traced back 5,000 years, because some evidence found regarding the dyed fabrics in the tomb of Egyptian period. So on your screen you are looking some natural plant products, that is, you are looking here turmeric powder, some stems, leaves, saffrons. So all are the plant products which were used or which can be used in the form of dyes. Learners, throughout the life people used to dye their materials locally, dye their fabrics or dye their required things from the local available materials. Nature has used generous amount of colors in almost all its creations. If we look around us, we will find in nature every creations have a particular colors or a different shades of colors, like natural invertebrate. Natural invertebrates are insect, some sea invertebrates like seashells, snails, mollusk, octopus and worms. These are the natural the dyes obtained from these natural invertebrates called natural dyes. One important example, Tyrian blue or Tyrian purple and crimson kermes. Crimson kermes, crimson is a word which is derived from a kermes, which is an insect and found on the stem of oak plants. So that dyes obtained from the crimson insect, and that dyes are very highly prized luxury items in ancient and medieval words which contain brilliant and permanent color. On your screen you are looking snails. This is a natural invertebrate found in sea. So, the color or dye obtained from this snail is Tyrian purple. Learners, it was a symbol. The in Roman emperor used that purple color dyed. It was a symbol of status in that time, and it was a very highly priced luxury dyes that time. And can you believe 1.4 gram of Tyrian purple dyes? For obtaining that dyes in 1.4 grams, over 14,000 of snails were crushed. They take out the glands of snails and then dried, then form this Tyrian purple or royal purple dye. So, it is very expensive, it was very expensive and very complex to produce. And then item and the color was they obtained in that time was a purple color, and it was associated with the power and wealth. Similarly, plant based dyes such as wort. Wort is a family of mustard plant and it is having a yellow color flowers. So, from that flowers and leaves of that wort plants obtained different color dyes, especially from leaves of wort plants we get a blue color dyes. Similarly, indigo, saffron and madar, some commercially used dyes and were important trade goods in economics of Asia, Africa and Europe. Learners, after Industrial Revolution, the discovery of man-made synthetic dyes in 19th century takes place and they were used commercially in the textile. In early 21st century, the century in which we are living, the market of natural dyes in fashion industry is experiencing a resurgence because the natural dyes are non-toxic, non-allergic and natural dyes are biodegradable also, environmental friendly. Also, one important characteristics of natural dyes are the natural dyes absorb a good amount of UV radiations. The radiation which we get from the sun rays, these natural dyes absorb a good amount of UV radiation. So, we can say the product or the textiles which dyed from the natural dyes are very safe for skin. Western consumers have become more concerned about health and environmental impact of synthetic dyes because many of dyes are very harmful for our skin, for the environmental also. A few examples of natural dyes and their sources are: first, we will see animal derived dyes, the dyes which we can obtain, which we can produce from the animals. One dyes, that is a insect, Carmes insect, and from that insect we can get red dyes. Similarly, cow urine. From cow urine, in ancient times, the Indians were used to produce Indian yellow from the cow urine. And what was the procedure? You will surprise. For getting the Indian yellow color from the cow urine, they dried the urine of cow, and also they, for this yellow color, they feed the cow only for, they use mango leaves and leaving the cow in the state of starvation. So, you can understand how it was difficult to get the Indian yellow from the cow urine. The cow were used to forced to feed on the mango leaves only. Similarly, lac insects, from lac insect we get red and violet color dyes. Snails, as I told you in previous slides, purple or blue indigo. Octopus or cuttlefish, these are the sea invertebrates. We get the manufacturer were used to get a sepia brown color dyes. And on the screen you are looking Acacia catechu. So, Acacia catechu is a plant. The manufacturer was used to produce the red color dyes. So, as again you can see snails, from the snails they used to obtain premier luxury dye of the ancient worlds. Another types of dyes which we can get are from the plants, which the dyes derived from the plants. One important, everybody knows about it, henna. In locally we call this mehendi. Henna, it is a reddish brown dyes which is obtained from the leaves of plant, that is Lawsonia inermis. And learner, the organic compound which is present in henna, that is hydroxynaphthaquinone. So, that is the organic compound which is responsible for the giving the reddish brown color of henna. Similarly, another plant derived dyes is catechu, that is katha. Locally we called it katha. It is a source of brown dyes which is obtained from Acacia catechu plant, and it is used for imparting brown and khaki colors to the fabrics. Learners, this catechu or katha, it is also used for chewing along with betel leaves, also called pan, which impart reddish brown color to the tongues and lips. So, these are certain chemicals which is present in catechu, and that chemical compound gives the red dyes or red colors to our tongues, to our fabrics, to and the textile industries also. Another important plant derived dyes is turmeric. So, turmeric, it gives reddish orange natural dye, and it is obtained from the plant Curcuma longa, and it impart yellow color to the food. And the learners, very important, the yellow color of turmeric is due to presence of a organic compound, that is curcumin, which is a highly conjugated functional group. So, due to presence of curcumin, which is a conjugated group, turmeric gives red orange color. Also, in presence of alkali, curcumin imparts red color to the formation of quinonoid structure. So, that curcumin, when we treated this turmeric in alkali or in soap, you will find out at your home also. Though in that case, the curcumin which is present in the turmeric powder change into quinonoid structure. Also, this turmeric powder used as an antioxidants properties in cosmetics preparation and as a preservatives. Similarly, another important plant derived dyes which we can obtain from the walnut shells. So, you can understand everything is important in nature. Walnut shell, we provide these walnut shell we can get manufactured used to take out the brown color dyes, and that brown color dyes is due to presence of quinonoid structure in them. Similarly, madar root, this is a madar plant. So, root of that plant is used to take out red color dyes. Pomegranate, that is anar, it gives the rind yellow dye. Similarly, teak leaf. From teak leaf we can get crimson to maroon color dyes. Another important plant which is the source of tannin, that is Rus tiffinia, and it gives the brown color dyes. So, tannin is a compound which is present in the leaves of Rus tiffinia and it gives the brown color dye. Learners, madar, it is a plant, was dye of commercially importance in Europe, being cultivated in Netherlands and France to dye the coats of military uniforms until the market collapsed due to the development of synthetic alizarin dye in 1869. So, madar, it is a plant, and from the root of madar plant we can get the beautiful red color dyes, and it was used before the 1869 because madar roots contain alizarin. Alizarin is a organic compound which is present in the root of that plants. So, after the discovery of synthesis of alizarin, we use to take these synthetic dye for dyeing the textiles. Learners, these are the beautiful roots of madar plants, and you can see here after drying the seeds or roots of madar plants, we used to take out the red color dyes. So, it is a beautiful roots of that plants give beautiful red color dye. Learners, now question is arising here, how we can describe the dyes? What are the dyes? So, dyes are what? Dyes are the chemical compounds or organic compounds which can be chemically bonded to the substrate on which it is being applied, or we can define dyes are the chemical organic compounds used in solution to impart color to various substances like fabric, like paper, leather, drugs, cosmetics, plastics, and also in food materials. Now, what is the criteria for a compound to qualify for a good dye? Number 1 criteria, the substance of a suitable color. Number 2, the substance which is used as a dye should be capable of fixing the color to the fabric. Number 3, it must be fast and resistant towards water, dilute acids, alkali and various organic solvents. And one important point is the substance should have ability to resistance washing, dry cleaning towards heat, light and moistures. So, there are two types of dyes, the dyes that permanently fix on the surface of fiber or that can make a bond, dyes always make a bond with the fibers. So, the dye which is permanently fixed on the fiber are called fast dyes. Similarly, whereas the dyes that fades out or washed off called fugitive dyes. So, the fugitive dyes make a very weak bond to the fabric. So, that is why they easily fades out or washed off. Learners, no definite procedures for nomenclature of dyes commonly known by their commercial names given by manufacturer. Society of Dyes and Colorist has proposed a color index and each dye is to given a color index. Learners, color index are simple numerical expressions and given to each of the dyes and used by the peoples, used by the colorists who are involved in the color business. Now, learners, how are dyes related to the colors? How can we associate dyes to the colors? Dyes possesses colors as they absorb light in visible spectrum. Light that dyes contain color bearing groups. Very important points. The dyes which are using in textile industry, in pharmaceutical industry, in food industry, in even beauty industries also, that contain color bearing groups called chromophores or oxochromes. So, oxochrome is a color helping groups. It intensify the colors. Also, that dyes should contain a conjugated system. The exhibit of, due to presence of conjugated system, resonance of electrons, which is stabilizing force in organic compounds, takes place, and due to that resonating structure, excitation of electrons takes place from lower state to higher state, and we get able to see the colors. So, but when any one of these features or any one of these criteria is lacking from the molecular structure, the color is lost. We cannot say that is the dye, right. So, what are the colors? Have you think about it? We are looking different colors. How can we define the colors? Learners, colors are nothing. They are electromagnetic radiation energy, which is composed of different wavelength. So, we can describe colors are electromagnetic radiation energy. An organic compound, because we are talking about the dyes here, dyes are the organic compounds. So, an organic compound appears colored only if it is absorb the radiation or absorb the radiation energy in the visible part of EMR spectrum, electromagnetic radiation spectrum, right. So, white light is visible region extend from 400 to 800 nanometer in frequencies, and that white light consists of 7 colors called, we can represent it by in a short name VIBGYOR. VIBGYOR is a violet, indigo, purple, green, yellow and red. So, that white light in visible region consists of these 7 colors, VIBGYORs. So, this is a table. You can see here the colors and its wavelength. At what wavelength we can see the colors of a particular dye. Red colors appears in the wavelength between 630 to 750 nanometer. Similarly, orange color can be appear into 590 to 630 nanometer frequencies. Yellow colors 570 to 590 nanometer of frequencies, and similarly you can see in the table green, blue, indigo and violet. So, there are certain frequencies for each and every colors. So, and you can see the frequencies wavelength lies between 300 to 800 nanometer in visible region. So, learner, it is a graph between absorption of radiation and wavelength. So, here we will observe the color in visible region only. Learner, what happened in ultraviolet region? The ultraviolet, in ultraviolet region it extends from 100 to 400 nanometer of frequencies. Our eyes cannot able to see the color in ultraviolet region. So, learners, always remember we can see the color in visible region only. So, these are the list, this is the list where we can find out the wavelength, color and finally the color which we see in here. One example I would like to tell you, the last color in it is in 605 to 750 in nanometer, and the colors is red color, but the color finally we will see blue green color, that is called cyan color. So, here different colors and having different frequencies, different wavelength, and the color which we will see finally in visible region is different colors. Like blue color, in blue color wavelength appear in visible region is 480 435 to 418 nanometer of frequency, but finally we will see the yellow color. The color which will be seen in the visible region will be yellow colors. So, learners, when white light falls on any object and it gets totally reflected back, the object appears white. Similarly, when this white light totally absorbed, the object appear black. So, must understand or must remember, a part of light is absorbed and rest of the light is reflected back, then the object appear colored, right. So, it is very important point, when a part of light is absorbed and some part of the light is reflected back, then we would able to see the colored object. Now, what is the relation between color and constitutions of dyes? How can we associate colors and what are the constitution present in the dyes which is responsible for the colors? Learners, there are different theories. One theory is Witt's theory of colors. Owen Witt in 1976 proposed a chromophore oxochrome theories. He found that, he observed that while working on the dyes, while working on the some organic compound, he observed that some colored compound contain unsaturated groups, which is called chromophores. Chromo means colors and phores means to bear. So, certain organic compound which contain chromophore, and he has given chromophore oxochrome theory. Chromophore are color bearing group, but oxochrome are color deepening groups. So, example, in the example you can see this is a benzene. Benzene having no color, it is a colorless because there is no group present over here. But if we see the another example, that is a nitrobenzene. Nitrobenzene is pale green color because of the presence of NO2 group. If we move towards the third example, there is a particular N double bond N group. This is a chromophore. Due to that chromophore, it gives the orange red colors. So, learners, there are some important chromophores, that is carbon double bond, cyano group, carbonyl group, azo group, nitro group, nitroso group, or quinoid ring, quinoid group, C double bond S group. So, these are the some chromophores, and these chromophores, due to presence of that chromophores, absorption of light and conjugation of electrons takes place, which is responsible for the color in visible region. So, learner, in this part of the lecture, we have seen, we have learned what are the dyes and how can we obtain dyes from the plants and animals, what are the how the dyes are associated with colors, and what the important organic compound or functions present in the dyes, due to dyes are able to give the one different or a particular color in visible region. Learner, in this second part we will continue the importance of dyes, and we will see how dyes have different groups or what are the different theories and classifications of dyes. Thank you.